Okay, good morning everyone. I don't know, there was something wrong with the connection or something like the stream key or something. Okay, anyways, we'll start it. Yeah, just give me a minute. Yeah, hope now it is streaming well. A connection or something like. I had updated the same stream key, but then again it did not work. So again I closed the system and again I switched it on. Then it started working. So sometimes it happens, technical issues will be there definitely. Let us move on to the different concept in the class. Okay, so myself Priya and I'm a top educator in the category of EAMCET. I have been teaching on an academy platform from past 4 months, and I take coaching for CET students, and also in the offline mode I have been teaching for different category of students. That is JEE, NEET, and also CET category of students. Okay, yeah, let us move on. I'll try to take up as much as concept as possible in this particular class. Yeah, so this is about the plus subscription, and all of you can opt for plus subscription. That is, there are three different plans. One is a 12-month plan, which costs you around 12,375 rupees. There is a 6-month plan, which costs you around 10,125 rupees, and also we have a 1-month plan which costs you 2,250 rupees. Okay, so the 12-month plan is having a EMI option of 1031. Likewise, 6-month plan also has an EMI option of 1688 per month. And this 1-month plan, it is a trial price and is applicable or available only for the new subscribers. Okay, so you can use this code PRKLIVE in order to get 10% off on any of these subscription plans. So under this subscription plans, you will be getting premium content at very affordable price, structured live courses and dedicated live doubt clearing sessions will be organized, and there will be quiz organized at regular intervals to analyze your knowledge, and also there will be separate batch for preparation of the subject. Daily practice papers will be provided. Mock test will be conducted, and under a single subscription, you can have unlimited access to the content on Unacademy platform. So all of you can opt for this plus subscription and use the code PRK live. This is about the EAMCET Rankers Badge. All of you can join this Rankers Badge and enhance your subject knowledge. Yeah. So you can also go to the description box of this particular YouTube session where you can find the link to my profile on YouTube on an academy platform, and you can follow me there, attend my classes regularly, and take the better advantage of the topics that are being dealt there. Okay, so please go to the description box of this particular video and follow my profile on an academy and attend the classes regularly. Thank you so much. Let us begin with the class. classification of elements and periodicity in properties. So introduction for this particular chapter we have seen. Let us move to the next very important form of periodic table, that is known as modern periodic table. Modern periodic table, also known as long form of periodic table, also known as long form of periodic table. So this is modern periodic table. Modern periodic table is also called as long form of periodic table. So what this modern periodic table or modern periodic law states? The modern periodic table was proposed by a very famous scientist, that is Henry Moseley. You can see his image is being placed on the right hand side of the screen, and the physical and chemical properties of elements are periodic function of their atomic numbers. So this is called as modern periodic law. The physical and chemical properties of the elements are periodic function of their atomic numbers. Okay, so here, but Henry Moseley for the first time proposed the concept of arranging the elements in the increasing order of atomic numbers, and he was very successful in arranging all the elements in their increasing order of atomic numbers. So the periodic law stated there were 94 naturally occurring elements. Neptunium, plutonium, and actinium and protactinium are also found in pitchblende and ore of uranium. So there were almost 94 naturally occurring elements, and while arranging the elements, Henry Moseley made certain vertical columns and horizontal rows. So he called the vertical columns as groups. He called the vertical columns as groups, or also known as families, whereas the horizontal rows, they were called as periods. So there were around 7 periods and 18 groups in the modern periodic table when he proposed it. Okay, so 7 groups and 18 periods. So all you can see these vertical columns, they are called as the groups, whereas these 7 horizontal rows, they are known as the periods. So when he was placing the elements, he made sure that all the elements with similarity in properties are placed in the same vertical column, that is one below the other. The elements with similarity in properties were placed in the same vertical column. So based on that, there was some different blocks of elements in the periodic table. So there are 4 different blocks of elements in the periodic table. Now what are these different blocks? Let us just see. So there are 4 blocks of elements in the periodic table: S block, P block, D block and F block elements. So what is this classification based on? How did he actually made these elements in S block or P block or D block or even F block? So the elements in which the last electron goes to S block or S orbital, the elements in which when you write the electronic configuration, if the last electron goes to S orbital, then we call it as a S block element. We call it as S block element. For example, group 1, which are known as alkali metals, that is, if their bases, if they are soluble in water, then we call them as alkali. And group 2, these are known as alkaline earth metals. These 2 are included in S block. So S block includes first and second group elements, that is alkali metals and alkaline earth metals. The general electronic configuration for alkali metals, which are first group elements, if you can just try to write the electronic configuration of all those elements, in the last orbit you can find that there is NS1 configuration. N can be any of the number depending on the orbital. So in last electron will be in the s orbital. Likewise, if you go to group 2, elements, the last electron goes to again s orbital, but their number of electrons are 2 in the s orbital. Right? So s block elements are when the last electron goes to s orbital, then we call them as s block elements. Group 1 and group 2 are included in s block elements. Group 1 elements are called as alkali metals and their general electronic configuration is ns1, whereas group 2 are called as alkaline earth metals and their general electronic configuration is block element is ns1. Okay, I don't know, there's some issue. Let us see. Okay. So we were speaking about the p block elements. Now it's fine. Okay, so coming to the next block of elements, that is the d block elements. So as the name itself suggests that the last electron would go into which orbital? D orbital. The last electron would go into the d orbital, right? So if in any element, if the last electron goes to the d orbital, then we call it as a d block element. So it includes the d block elements. They are included from group number 3 to group number 12. Group 3 to group 12. All these elements, they are included in the F block. They are included in the D block elements. Okay, so D block elements includes element from 3rd group to 12th group. So you can just see their electronic configuration. Generally we can write it as n-1 d 1 to 10 and then 1 to 2. So this d orbital, you know, capacity of d orbital is maximum 10. So here it can occupy from 1 to 10 electrons, and s orbital can also have 1 electron or maximum of 2 electrons. Now this d block elements, they are very important because they show catalytic properties. D block elements, they show catalytic properties. They form colored ions. They show paramagnetic properties. They form complexes. Okay, all this you will be learning in second year when you are taking D block, D and S block elements. When you're learning about coordination compounds, all these topics you will be dealing up there. Okay, so this D block elements, as the name itself suggests, they have elements from group 3 to group 12 and the last electron would go into the d orbital. General electronic configuration is n-1 d 1 to 10 ns 1 to 2. Now these are usually placed between p block elements and the s block elements, and as they are placed between p block elements and the s block elements, they are called as transition metals. They are called as transition metals because they show a change in property. They would show a change in property from s block elements to p block elements. Let us go to the next slide. Okay, so next one is the F block elements. F block elements, these are quite difficult to understand, but then basics are there in this chapter. The F block elements, there are two types of F block elements. First, let us see what are meaning of F block elements. F block elements means if the last electron goes to F orbital, then we call it as F block elements. There are two types of F block elements, that is lanthanoids and actinoids. Lanthanoids and actinoids. Lanthanoids are those F block elements which are placed after lanthanum, and actinoids are those F block elements which are placed after actinium. So lanthanoids and actinoids are present. Then now coming to the general electronic configuration of this lanthanoids or actinoids, or even generally F block elements, it is N-2 F 1 to 14. Okay, 1 to 14. N-1 D 0 to 1 NS 2. Okay, this is the electronic configuration. Please make sure this correction is there. Now these are called as inner transition metals. Okay, D block elements, they are called as transition metal, and F block elements, they are called as inner transition elements. Very good morning, Apurva. Thank you so much for joining. Now, they have incompletely filled d orbitals in their normal state and in their oxidation states that are being observed, and they are generally radioactive. These F block elements, they are generally radioactive in nature. So that's about the different 4 blocks of elements. Now, coming to the different other trends that we need to study in physical properties, like we have to study about atomic radius, ionic radius, what is the definition of atomic radius, ionic radius, and what is electron gain enthalpy, what is ionization enthalpy, electronegativity, oxidation states. All these things we need to learn. Okay, so let us see one by one in details. Coming to first one, atomic radius. Coming to the first trend that we are going to study, it is about the atomic radius. The atomic size generally decrease along a period, as we have seen, because the elements are added to the same shell, and due to that nuclear force of attraction will increase. So when you go from lithium, which has around 150 picometer as its radius, and if you move along towards the right hand side of the periodic table, that is up to fluorine, it has very small, you can just compare, it has very small size. This is because at every step the electron is added to the same shell, and when the electron is added to the same shell, the nuclear force of attraction increases, effective nuclear charge increases, and therefore size will decrease. Size will decrease. So when you go from left to right in a periodic table, size decreases. But when you see from top to bottom in a periodic table, when you observe from top to bottom in a periodic table, size increases. Now why size increases? Because at every step a new shell is added. When you add a new shell, definitely the size is going to increase. The size is going to increase up. Okay, so this is about atomic radius. Now before going into that, we should have discussed this one. What is the definition of atomic radius? So if I write this as one shell, K shell, the distance from the center of the nucleus to the outermost shell is called as atomic radius. Good morning, Mangal Desai. Thank you so much for joining. So this is known as atomic radius. The distance from center of the nucleus to the outermost shell, it is known as atomic radius. The outermost shell can be any of them, that is K shell, L shell, depending on the electronic configuration of that particular element. So if you just observe this variation of atomic size, then you can see from lithium to cesium, that is down the group, from lithium to cesium, size will go on increasing. Why? Because at one step a new shell is added, therefore what happens is the size is group, but in a period it will decrease. Likewise, if you see in halogen series, fluorine, chlorine, bromine and iodine, so fluorine is the first member of the group, so it will be having less number of shells, so size will be less. But if you go down the group, then You can just observe that iodine will be having more number of shells. Therefore, distance from the center of the nucleus to the outermost shell will be very large, and therefore size of iodine is higher. Welcome, Tamali. Thank you so much for joining. Good morning. Very good morning, everyone. Yeah. So next is ionic radius. Ionic radius is nothing but the distance from center of the nucleus to the outermost shell in a ion. It may be a cation or it may be an anion. The cations are formed by loss of electrons, whereas anions, they are formed by gain of electrons in the parent atom. Now, you can say when loss of electrons are taking place, definitely the size of cation will be smaller than that of its parent ion. Correct? So, shell will be reduced. So, cations are smaller in size than their parent ions. So, next one is coming to anions. You can just see here, anions, they are bigger in size as compared to that of their parent atoms. Why? Because you can just take the example of nitrogen here. It is 2, 5. So here I'll draw 2 electrons in K shell, and in the next shell I can draw 5 electrons. Okay. Now if it has to complete its octet configuration, it has to accept 3 electrons. It has to accept 3 electrons. If it accepts 3 electrons, means -3 charge will come. It will be an anion. So this 3 electrons, if it is coming and joining up in this orbitals, definitely they will experience certain repulsion. From this 5 electrons and these 3 electrons, they will experience certain repulsion. Due to increase in the repulsion, the size will increase. Okay, the size of this particular element, it will increase, and therefore always we say that anions, they will be bigger in size as compared to that of their parent atom. Okay, so that's about the ionic radius, that is isoelectronic species. What is the meaning of isoelectronic species? Isoelectronic means, iso means same, electronic means number of electrons. So same number of electrons will be present in those pair of species. For example, if I take O2 minus and if I take neon, oxygen is atomic number 8, it has accepted 2 electrons. So total number of electrons in oxygen 10. Neon atomic number, 10. So it also has 10 number of electrons. So we say oxygen is isoelectronic with neon. We can say oxygen is isoelectronic with neon. Likewise, if I take F minus, fluorine with a negative charge. Fluorine, atomic number is 9. 1 minus charge is there, means it has accepted 1 electron. So I can say it has a total of 10 electrons. So now I will say all these 3, they are isoelectronic with each other. If they have same number of electrons, then we say they are isoelectronic with each other. So this is the concept for today. My next live YouTube session will be on 10:30 AM and the same topic will be continued. So if you have any doubts, you can comment in the comment section. All of you, thank you so much that you have joined, and have a good day. If you have any doubts, you can ask. So the next live YouTube session will be on 10th at 8:30 AM. Okay, and the topic will be continued, that is periodic classification of elements. Yes, thank you everyone for joining. See you on 10th for the continuation of this particular chapter. I'm just waiting for your doubts. If you have any doubts, you can comment in the comment section.